just making an explosion type thing here for destructible walls. Okay, let's do, I don't know. I don't know, man. Oops. Yeah, that should be okay. Probably want to do some variation on that, but all right, let's see if we can create a explosion here. So I guess I'll go through a little bit. So I've done a little bit of planning, and because I'm beginning to see, you know, the sort of maybe beginnings to the end of this project. Maybe we'll see what happens, if it's gonna be like a longer project or if I'm gonna just, you know, call it for the first area. And well, the first area that I was thinking about, I mean, there is potential to extend the game, so to speak, but I'm just not sure if, like, how long I want the game to be. But I mean, potentially could be very long and stuff, but since it's like, since I'm still very new in game dev, I probably want to limit the ambition a little bit more than I've been doing. But I'll just explain a little bit what this document is, because this is like sort of the planning for maybe the first sort of pre-alpha demo version. And I've included stuff here that is there's a lot of question marks as well, but well, one of the things that I want to do is destructible tiles and camera. That was what I was thinking of, that I was gonna try and do this stream or next couple of streams, maybe focus on these two things. And so otherwise we have some more gameplay stuff where we have fixing the jump sort of algorithm, or the jump equation, I should say. The jump right now is very basic, like just kind of feels a bit floaty sometimes. I did increase the gravity to kind of counteract the floatiness of it, but then there's still, you know, there's still some things that you can do with the jump that to make it better, like feel better. So I want to experiment a little bit with that as well. Then we have more combat techniques and abilities. Like right now, there's only one combat technique, and it's not really a technique. It's like more like you can combo attack. Like if you press 2 times on the attack, you do like a 1-2 combo, and that's it. That's what we have for combat. We also have the launch attack, but that's not really implemented properly, and I'm not even sure we're gonna go that route. I mean, it would be a cool thing. Maybe that's the route to go, like the combo input stuff. We'll see what happens. And then also more abilities. Like right now we have like a double jump, and well, we also have the upgrade lens sort of equipment that you can get, and which is not really fully implemented either now, because, well, it is implemented for like logical puzzles, but it's not. I want some combat stuff for that as well, like maybe stunning or slowing enemies, dealing damage, stuff like that. Then I have like magic question mark, which is like, okay, I know there's gonna be magic in the game somehow, but I'm not sure exactly how I want it to be, but we'll see. And then, you know, I want, of course, you know, basic stuff here, music and sounds. And then we're gonna have these 2 areas. So that's basically it. And what's gonna be in the forest area is the, well, base time maps, just the map, you know. Backgrounds, I have to fix the backgrounds. Adding puzzles that you solve to get like loot and stuff. And the upgrade, which is the lens. I mean, it's just a matter of implementing, getting an upgrade, like getting some sort of equipment system and stuff. The boss, of course, monsters. We have a lot of monsters, but for the first area, but I feel like we need I need at least one larger monster. Like right now we have a bunch of small type monster, but I would like to have some sort of larger monster that is like a bit slower and that takes a bit longer to kill, and maybe produce more loot. Secrets. Yeah, just a bunch of secrets that we want to add, and that goes also hand in hand with the destructible environment stuff, which is gonna basically be just, you know, you're gonna find maybe a secret in a wall somewhere where you hit the wall, you open the wall. Yeah, that's basically it. You're not gonna be able to hit everything and destroy everything, just the places where you have secrets. And of course treasures, which right now we don't really have anything to get except for gems. So there's there's not really that many resources to get. It's just gonna be I guess a box of gems that you're gonna get. Yeah, and then the village is kind of bare bones right now. You can't go into buildings. There's only like demo. There's only like a debug elder NPC and 2 sort of guards that don't do anything basically. And so yeah, so I wanna like flesh out the village with some more interesting NPCs and also introduce some sort of quests. Maybe we'll see what happens. We do have the system for quests and dialogue, so it's just a matter of adding the content there. And also, since we have gems, we might need something to spend it on, so that would be some sort of shop where you can buy, I don't know, something like a life upgrade maybe, or something like that. So yeah, that's basically it for the first like pre-alpha version that I was thinking about, but I don't really want to label it that as that either, because I'm not sure if that's gonna be the end of it. We'll see. It's kind of growing naturally, so yeah, we'll see what happens. But anyway, I want to focus on these 2 things, and I started thinking about the camera system, where I want it to be sort of, as I said, they're dynamically bounded, which means that the camera, I mean, it follows the player, of course, but it also gets bounded by the surroundings, so it can't go past the 2D sort of wall that's at the edge of a map, for example, or the ground or the ceiling. But then what if you have an area that's shaped like a T and you go to the middle and all of a sudden you have a vertical section? There the camera sort of is supposed to unlock at the vertical axis, and you can go down. So, and also dynamic means that, let's say you destroy a secret wall, well, then the camera should reveal what's in the wall, but before you destroy it, you shouldn't reveal that there's more at that point. So the camera should stay bounded, but then you destroy the wall, and the camera should be unbounded at that point. Or I mean, it should still be bounded, but the boundary sort of changes depending on if you've destroyed the destructible tile or not. But before we can even do that, we need destructible tiles. So now I'm working on adding destructible tiles. So I added the graphics for sort of like a one-way destructible thing, where if you approach from one side, you just see a wall, but if you approach from the other side, you see a hidden sort of machine that you can activate, which will destroy the wall. So that was what I was thinking there. Now, how would this work now? So let's so we have the graphics already, so I'm gonna create a new entity for the, I'm not sure what to call it, maybe like device explosive or something, I don't know, wall, explosive wall, let's call it. All right, let's grab the devices here, and here you can see that. So this is the device here, and so let's grab this graphic there. Now I'm not sure, so I don't think we need maybe properties for this. This is just basically going to be, the idea is it's basically going to destroy a 3 tall wall, because yeah, 3 tall is basically the normal size for like a corridor or a hallway or something. Well, it's the, I guess it's the lowest part. Well, let's see. So this is device explosive wall. Okay, so we've got that now. Let's create some animations for it. So device explosive wall. All right. And let's create. So we need an animation for idle. It's just gonna be that. And then explode. And you can see it's sort of modeled like it sort of has a charge here, and then when you activate it, it's just gonna rapidly send this sort of charge into these funnels or channels here, and at this point of exit, it's gonna expand out into the wall and explode like this. So, and then the idea is that basically you can see it sort of ends abruptly here. But the idea is that we would spawn a bunch of these explosions over here, which will sort of cover the whole thing. So you don't really see beyond this point. Like at this point, at the frame 5 here, we basically summon a whole bunch of explosive over here. And it's gonna just cover the area with a bunch of explosions. And then the wall is gonna disappear basically behind that. So... and then this entity will also like just disappear behind that. So that's kind of the idea there. Okay, so that's the explosion there. Explode. Or actually, this could be called activate actually. Let's call this activate. Because I want another one called explosion. Oops. Which is this one here. So this is the explosion. So I want to spawn a whole bunch of these explosions to sort of cover the area and then just remove this behind it. So yeah. Let's see, do we need to like... I don't think we need to sort of change the... Maybe actually the last frame will keep it on there for a bit longer. We have to like... Also, I think it should go a little bit faster actually. Maybe. I mean, you still want to see it happening. Maybe. I don't know. Okay, let's just start there and see how that works. Okay, so there's our animations for whatever it's called, the wall explosive thing. Yeah, device explosive wall. Yeah. So if we go to, let's go to scene. Let's just close everything here. We go to map. And where would we have this? So I think what we want to do is we want to have it. So the idea is that you would go from the village and you go all the way over here, So you will block down here. There's a door here with a strange device that you can't get through. So you're blocked there. Then you go over here, and then the same thing is here, but I'm not sure if this is going to be more hidden down here. There's going to be like some sort of passageway down, which is also blocked with this strange thing. So possibly this could be where we have this entity, and it will blow up here, and then you can enter. Then there's going to be a tunnel section over here, and then another small like treasure area over here that you can get. Although I'm not sure what the purpose will be of this tunnel actually, because let's say you play this game already and you know that there's no point in going down here because the treasure's over here. So you can just skip all that and then go directly down here and over there. Unless we make this inaccessible, we can remove this one and make this sort of inaccessible from below. Yeah, but anyway, the idea is that when you go over here, you're gonna meet these places where, oh, there's a door here, so you can't go past it, you can't find a way to open it. Or same way over here, there's some sort of passage down here. Then you go up here, same way over here. Here's a thing where you can't go through here. And there's supposed to be one here as well. And then over here, we should have something here as well, which blocks it. So you're forced to go all the way up here. And this is where you actually get this upgrade here. So you get the upgrade, you go through here, this is open. You go in here. Also, we need a thing here, which when you go through this point or you enter some sort of region here, this is gonna close. So we need some sort of entity for that as well, which is sort of like an invisible entity, I guess. But then you go in here, you get the item, you learn how to use it, you solve a bunch of puzzles, you go back down here, and you go, and now you can enter all these areas, but you go in and fight this, or I mean, you can go in here and get the treasure up here, and then you can also explore, get treasure down over here, and then this is the last part that you haven't explored. So this is the well, I mean, if you do it that order. But then you can go here, you can go through, you go up here, you go over here, and then you get to the boss, and you kill the boss. And then the idea is that you would also open up like a shortcut over here, maybe, to get directly in, back down here, maybe. Well, we'll see what happens. But and then when you go back, you have to backtrack all the way over here, but then there's new stuff down here that you can access now. So you go down here and you go through a tunnel here, and then here's the treasure, and then you can go up, back up here. Or maybe, I mean, maybe this is bad. Maybe this should be, maybe this downwards should be over here, because then it becomes easier to get back. You don't have to go through all of this. You have to just go back out here. I really appreciate when a game has good shortcuts, and I don't mind having like a long section that you have to fight through to get somewhere, but I do have problems sometimes when you have to backtrack through that same area over and over again, and there's no shortcut. So I really like those kinds of shortcuts. So instead of like going up here, you have to go through all the way back. Maybe we should just open up a pathway over here instead and go like that. So yeah, so but over here some sort of treasure, and then you go back, and you go back to the village and turn in some quests and stuff. So that's the idea. And then over here is just area that's basically not really used. Okay, and then that's basically it. So that's basically what is left to do, I think, for this sort of first pre-alpha version here. So let's see. So where could we put one like destructible thing? I think I want to do the change here. So I think I want to open up here and change this a little bit, so this would connect here instead of here. But then what would the purpose of this be? Maybe this is like a secret. Maybe there's a wall here, and you can destroy that wall and then find a secret over here. That could actually be something there. So let's actually just fix that real quick here, because that should be pretty easy to fix. So instead of going down here, which is 4 wide, we should have a thing down here instead. So let's do it 4 wide there. All right. So over here is basically, this is gonna be nothing down here then. It's just gonna be this. Right. Okay, and then over here is gonna be like a wall here. Okay. And then this is like the secret area. Now I'm not really sure how to do with secret areas. We don't really have that implemented right now. So this is gonna be something that is gonna be implemented in the future, but okay, I'm not gonna do anything there. All right, and then if we go back to the entrance to the scene, we'll just remove this, I think. Yeah, I think what we'll do is we'll have a door here. Let's remove this monster as well. And we'll have a trigger at the other side that you're gonna open, which will open both this and another door below. Also, I realize this is probably too high here. We need to move this down. And we need to change the time map a little bit. There we go. Well, let's do this. Alright. That should be fine. Okay, so now you get a downward path directly here, which kind of maybe looks a little bit weird, I don't know. So you have to jump over that because there's like a door there. But yeah, anyway, so that should be fine. Also, we could probably remove you. We'll keep this guy there. Okay. Yeah, because now this one is, yeah, you can see now this has moved over here, so it's connected like this instead now. And yeah, so it's basically you can go the tunnel way to go, you don't have to go through this again. You go the new way, and then when you get back up, you get back up here and then back down over just this short while to the village here. Right, now for the destructive wall thing. So the destructive wall thing could be used in several ways. It could be used to just have a path that is blocked by the first upgrade that you get. It could also be used as a sort of, you have to get to the other side to be able to pass this point, because it's like a shortcut unlock type thing. But what I'm thinking here is we should open up somewhere here, maybe down here or here. Oops. Let's do foreground. And well, we need a way to jump over. I think I'll just do this, and there's 3 high there. That's fine. So we'll open up a little bit like this, but then you realize that, oh, there's a thing over here. And wait, how is this? Because I'm thinking about how the camera should work as well. So let's say you go into this area. The camera should not go below this point here, because if it does, it sort of reveals that there's something below here. Well, this area is like also available, I guess. So it could technically go down here, but at the start area sort of over here. When you move to the left, this is revealed. So it could be that the verticality is sort of unlocked over here. I don't really know exactly how we'll do it, but that will reveal that there's something below here, but it shouldn't go below this point, because then you know there's more downwards. So I want to have the camera sort of, it should reveal things, of course, but it shouldn't reveal secrets. That is, it shouldn't spoil the secrets, you know. But you go in here, you go down. What I'm thinking is, if this is a secret path over here, it shouldn't reveal everything down here. So maybe everything down here is like hidden behind a secret fog of war or something. I don't know. I don't know what the term is, but that could really be something there. And we'll have some stuff down here. Where's that? Here. Right. And now, actually, here now we need this entity. So, oh, but I only have left. Wait. All right, this is the tile set. No. Wait. Yes, it is. So hill entrance. Oh, let's just remove all this crap here. Alright, this is the hill. Also, I really need to fix the camera here. When you switch the camera, they share camera, so it's like when you switch it, since the time map and the scene editor doesn't share, well, they share camera, but they don't share the same like origin point of the time map, which is really bad. So either I will change the origin point of the time map, or I will change how the camera works. Like that, it should probably be a different camera for each editor, to be honest, because this is, yeah, it should really be a different camera, because it should like save whatever thing you're doing here. So actually this is now the wrong way, but the idea is, let's say we put it over here, so that the idea is it's like this in the wall, like this, and then maybe we'll have some sort of tile that you can put here to like finish this little part here. Or we could use maybe we can use we could use this thing here for now. Yeah. So you can see it doesn't really look that good. We should probably have like a custom thing for that. But this is embedded sort of in the wall, and then when you activate it, it's gonna sort of play the active animation. We're gonna spawn a bunch of explosions, and at the end it's gonna sort of, I guess it's gonna do some sort of destructive thing here. And I guess maybe it's gonna depend on which one it would be. I'm not sure if I'm gonna have it like fully dynamic, that you can fully dynamic is a vague term here, but fully customizable from the editor, and choose which tiles are gonna be like. That's gonna be a lot of work just to get that working, to be able to do that. So what I'm thinking is we'll probably just, since we're probably not gonna have too many of these, maybe like, I don't know, for the first area probably maybe 2 or 3 or something like that. Probably they're just gonna be hard coded in the game to actually just, okay, let's just look for any tiles that are here, and then we just destroy those tiles. So that's the idea. Actually, maybe it should be at the right side. I was thinking it should be over here. It felt like a good idea, but maybe it should be over there. All right. Wait, why is that? Oh, this shouldn't be in the foreground. It should be in the background. And then we also have this one as well. All right. Actually, you know what? Let's actually try and fix this right now. I want to fix the cameras here, so I'll just save all the scenes here first, so we don't lose anything. Let's go to the editor. Editor doesn't really have much. We only have document and a convenience thing for document type. So which we should probably just remove, I guess. But we should have like a camera here, so let's add that. So get relive camera 2D. Offset, target, rotation, zoom. All right. Now the target is, I guess, a little bit weird. Let's go to context camera. It's set to 0. Yeah. So we'll remove this camera. But we still need these. Yes. All right. So those. I'm just checking if we need to clean this up a little bit. So we have the camera there. Okay, so then yeah, now we should get a bunch of compiler errors. Oh, we get this bullshit error. This is part of like an issue we had with adding tests. So we have these tests, but there was a problem with the imports because importing root is apparently not a good idea. So we changed lib to be, which is, sort of includes all of the common code, you could say, in the project, and you put it basically anything that is not in this file, I guess, and the main file. But now we get this weird error, which no module named lib available in module roots, which is wrong because the compiler actually doesn't complain. It's just the LSP that complains. So I don't know what's happening with that. But what we can do is try to run the thing, which will run the compiler with the sigbuild run. And we can look at the log here and see that now we get a whole bunch of places where we need to fix the missing camera stuff. So self is context. So what would this be? This is like restoring the session. That's correct. So now actually we should store the document. We should store like the editor's camera state as well. Actually. Oh yeah, and the session file, we don't have a version thing for that. Could also add the version. I'm not gonna do it right now. So camera, this doesn't even make sense now because we have no camera on context. What we need to do is we need to go to editor session, and we have open editor, open documents. Now open documents should be not only UUIDs but also cameras, I guess. Editor session documents. Now in the event that a document doesn't need a camera, then it doesn't really matter. But for now I think we'll just add it anyway, so then we just don't use it. Okay, that's the camera there. The initialize. Alright. Now here is going to be editor session document, and this is just going to be ID as well. ID. Okay, there we go. Right. And now we should get other compilers where we create the session, store session here. Create editor session. So, oh, we're not even saving the camera. Interesting. So open documents. This was very easy to do before. Now it's a little bit more tricky here. We should create editor session documents, I guess. So we'll do allocate, and we'll do count. There we go. We need to import this. Alright, so now we have that list. We can return it. We need to populate it, so we'll need to go through. Now documents so this would be equal to open editors no map. Actually we need to do this. So this one is map dot Well, ID is equal to map.keys I, and then camera is equal to values dot camera. There we go. Okay. Let's see what else we have to do. Right, 76. Right, so now in restore, this is a document, and the ID is going to be document by ID. So we're opening the editor. Do we get the editor back? No, we don't. But we could get the editor, open the editor here. And we could get this, and we can set the camera to document for camera. Well, we can just do this. Yeah. All right. And then at the end we do this as well, but then we don't need to set the camera because it's already set up here. Okay. Now we don't need to do anything with that. We should be more errors. Wait, 77. What's this? Cannot assign to constant. Oh, get. Do I have to say get pointer? Okay. No field name camera instruct content. Okay, here we go. So this was the one I was thinking about, probably. Yeah. So this is depending on the editor, on the current editor. So actually, the camera mode should be like in here instead. This would be editor of camera now instead. There we go. And also, yeah, when we update the camera offset, we are getting the current editor. And if we don't have an editor, we should just return. Now the camera, editor.camera. Well, let's just do editor camera instead. All right. Is there anything else we need to do? Layout, animation, camera controls. Wait. Oh, this is a different one. Right. Wait, but what is the other one? Update camera offset. Oh, this is only for the screen size, right? So if we resize the screen, this is gonna do that. All right, yeah. But this one, camera controls, this should be fine. However, where we call it from here, it shouldn't be from the context. It should be from the editor, which is nice because we do have editor probably in everywhere where we use this function. So we have to change this we have to just change it out. All right. Oops. scene map camera. Okay, so this is different. The scene map is special, so we'll keep that. Editor. And that was already fixed. Okay, there we go. Okay, let me just play this again and we'll see. No field name camera in context. Entity type. Oh. Right, this would be editor instead. If we really want this here. Probably have it in more places here. Yeah, layout scene. 43. Oh, we don't have editor. Wait, oh, we don't have editor in draw. Well, we should probably add it, but I guess what we'll do here is we'll say if context editor. No, we should have it. It's like there's no way we don't have an editor here at this point. So get current editor. Yeah. Scene layout scene 50. No field name, camera, and context. Yeah, so this is the same thing here. Same thing here. Here we should have the editor, I think, yeah. So we can pass that along. Oh, it's the same thing. Feels like we have a bunch of overlap here, so this could be a place where we sort of generalize some things, especially this position thing, because it's a bit long and it's being used in like at least 3 places from scene like right now, so this could really be fixed for the better, but another one, or no, just that over could change you. Oh, there's let's just search for camera. So here's another place actually. Here we could put editor. Alright, last place. There we go. What now? Layout time map. Okay. Yeah, since we're in draw, we have a document that we're associated with it. The editor should exist. So there's probably not an issue doing that. Layout utils. Oh. At this point, I think I'm also gonna assume that there is an editor, maybe. Yeah. Same thing here. Anything else? Here. Oh, here as well. And here. And here. All right. I think that should be it. There's a lot more places than I remembered to fix that. It was not really super trivial, but let's see. Do we have an editor here? No, we don't. But we should just be able to grab it the same way. Okay. Tool select. Yeah, should be same here. Filter equals this. I mean, it is a lookup here, but it's not really that big of a deal. Oh, right. The session is now in the session is now bad. Well, it's fine. So that's why we get this. Okay, I'm just gonna open this one. And I need to resize. Wait, it didn't work. Okay, I'll just resize manually. So, wait, this is not correct. Oh wait, that was not correct. Yeah. Let's wait. Projects close, open. Oh, that was. Oh, I see. That was my assets drive thing. It should be in dev. Here, there, and projects. Kottefolket. There we go. There we go. Here we go. All right. So, where were we? So now, yeah, now we have a map and stuff. Okay, cool. And what were we doing again? Oh yeah, I was doing the camera stuff. So if we open this one, yeah, you can see we have the camera here. Now if we switch between, oh my god, that's so nice. So now we can switch between, the camera is not messed up every time we switch. Wow, okay, that was really cool. Now let's just see if this actually gets restored. I'm gonna check for leaks and errors. Okay, that's fine. It's actually restored as well. Okay, really nice. So that's a nice one to tick off, because it's like, it's one of those things where it's kind of easy to implement, but it gives a lot of you get a lot of quality of life for it, and it just feels so much better to actually use the tool when you have stuff like that. Where do I have the camera stuff? Yeah, so now this is done. Awesome. All right, back to here. So yeah, so we need to implement this entity in the game code. We need to add it as a device, and when you trigger it, it's gonna activate the thing. We're gonna spawn a bunch of explosions. We're gonna remove the tiles sort of behind it. All right, so also, let's see, we only really need these 3. The rest here could be just deleted, I guess, and I will reveal a new area over here. So 3, 1. Yeah, I'm not sure exactly how it will look, but maybe something like this. We'll start there. Now the issue here though is that well, the issue right now, I guess, is like, sure, it will blow up here, but before that, this is still like visible right now in the game. So we need to also add a thing where we sort of hide this area until we trigger this one. So I mean, it might be built in. We could add like a property maybe, or we could just hard code the ID of the entity or something like that to begin with, to reveal this area here, and also remove the tiles. But we can start it. We can start by just creating the entity in the game code and activate the thing when we first step is just to spawn the thing. So because right now, let's say we move this over here, we press play, and now we can see here the the thing isn't even spawning here. So that's the first step. We need to spawn it. So let's go over to the game code. And we'll go to device. So let's just grab toggle. Could be a good starting point because toggle already has like activate on the beam thing. So let's do explosive wall. Let's do a search replace here. Toggle should be explosive wall. Okay. We also need to add this. And I need to add. I need to get the ID here from the animations. There we go. So now we have the animations. What else do we need to do? Well, now it sort of functions exactly like a toggle, I guess. So the state of the thing should be idle and activated, right? And I guess maybe we should have another state, because what's happening, like let's say if we go into the area again, we load in the area, it's gonna load in this entity. We should have a state that says that it's already been activated or it's already been exploded, or I mean, it should be like just destroyed. So we have a state called destroyed. So we set it to destroyed, which just removes it or prevents it from being created in the first place. Yeah, so let's see. Oh yeah, we need entity. We need it here as well. Explosive wall. Actually, here's called device explosive wall. But oh yeah, the explosive wall doesn't actually have any properties, so we'll just have it as like this. All right, and we can also add it over here. Explosive wall. Device. So now we get this, and we create a device type, door device, entity, no, not door device, explosive wall, but we should add that as well. So this would be explosive wall, device. Oops. Just boilerplating here. There we go. All right. explosive wall. No, that should just be draw layer T. Yeah, it's not accepting any sort of properties here, so we can just remove properties. There we go. Query from type to device. No, okay, yeah, this one is okay, yeah, it's just this one. Okay, so this one should be idle. There we go. And we don't have properties, so we'll remove that. Right, so get animation. I guess we'll switch. On state. Oops. Idle, so this should be idle. And then we have activated. I forgot what it was called now. Let's check that. Idle, activate, explosion. Okay. But then destroyed shouldn't have. This should be like unreachable. Well, I guess to make it technically work, we put idle there so it can maybe start the idle animation if it needs to do anything there. And looping should always be false, I think. Set state, yeah, that's fine. This could actually, like these ones, this could actually be, you could actually use like a mix-in for these things. I just realized, like, because it's the same for all of the things. Self is just this. Explosive wall, the state is just field type of this dot state, or it needs to be a name, so it has to be state like this, and then this is always going to be so true, and then this is just at this. And what you can do is put these things in a separate struct, which is like a, I don't know, has state or anything or something like that. And then you would use, I mean, let's say we put this in a struct like this. And then over here, what we can do is we can say using namespace has state. So now so now we can say, well, now, yeah, you can call set state. The only thing that is bad is that we probably don't get auto completion here now, but it does compile, and you don't have to type this out for every thing that's gonna have this kind of thing. But I think that we probably want to do that anyway, since to get better integration with LSP, maybe. I don't know. It's not that big of a deal right now, but it is like one of those things where you just feel bad copying pasting this stuff all the time. When you feel like, okay, we can generalize this instead. Maybe we can structure it in another way, but yeah, this is how it is right now. So because now here, okay, we don't even get we don't even get LSP help either now. I mean, do we even get, yeah, wait, okay, yeah, because on and off doesn't exist. But I'm trying to put this here. It doesn't complete to anything. It just completes to this garbage here, which is not from the LSP. So, but anyway, activate should be if the state is idle. Well, if it's not equal to idle, we return. Otherwise, we set this to activate. See, now we get it, but now we get this activate. I'm actually curious. Like, let's put this in a struct and see if we actually get that, because I'm pretty sure we don't get. I'm pretty sure we don't get auto completion here, but we'll see. So field, this is field, because you know we're using field type, we're using all kinds of weird stuff. All right, now we should get a compiler saying set state doesn't exist or not. Okay, but let's do pub using namespace and state. It does understand that we have this function, but I'm pretty sure, yeah, we do not get completion here now. So let's go back to this. You have to sort of, okay. Well, we do get it here. You can see it comes from NVM LSP, which means it's from the that's from the LSP. Okay, so we activated it. We just set the state to activated. We cannot deactivate it, so I think I'll just remove that function. There we go. Now the hitbox is also, I'll just lower the height or the width a little bit. All right. Otherwise, this looks good. Now where do we have a bunch of stuff here? Okay. So yeah, we should add things here now. Update explosive. I'm just copying this. So let's say if it's idle, we don't do anything. If it's activated, we want to check if the animation is done. Once it's done, we set the state to destroyed. I wonder if you could do this, like what? Now it's an enum literal. Yeah, the new state should always be destroyed, so we don't even care about that. I was just wondering what happens if we remove this type here. We get close, we get like enum literal. Can we still put this in here? Depends on, oh, it's a com time only. Okay, so you have to do this, I guess. Explosive wall state. Oh yeah, so if it's destroyed, I mean, we could just destroy it here, I guess. So what would that be? I think we add a, wait, we have utils. Oops. Utils. Destroy entity. This is gonna be this is just adding death. No, it's just destroy. This is destroying it. Oh, there we go. Mark entity for death. So we're gonna mark it for death, and the entity is the entity there. Yeah. So what this will do is it adds a death component to the entity, which then the death system will just clean up the entity there. Now, this does mean that there's basically going to be, I think there's going to be like, well, at most, I guess 2 or 3 frames before it's actually destroyed after the animation is done. But, I mean, that's probably fine. Right, activated. You don't have a state that I need to care about. Device type. So which one is this? This is handle state change. Right. Oh, we can do it there actually. Destroyed will not do anything. Let's do it handle state change actually. We switch on. We switch on the state. If it's destroyed, we do this. Let's just have it as a one-liner, I guess. If it's destroyed, we do this. If it's like idle or activate. Actually, if it's idle, we don't care. If it's... So we're always going to update animation. That's like inherent to all these device types. So we don't need to update animation. And that's basically almost everything that's happening in activate. So I'm just going to say nothing happens when we initially activate it here. Also deactivate... oh, I see. All devices need a deactivate function. Well, we could make it, well, okay, let's just create one that doesn't do anything, I guess. Fine. All device. There we go. All right. Now what you could also do is you could add, let's see, here you could add an if here, if has declaration, and the container is type of S, and the name is deactivate. So this means that if it has a function called deactivate, we call it. But if it doesn't have it, we don't care. So then you don't have to put it on everything. But I think it's nice to have I think it's nice to have it like this because it sort of enforces the thing to have the function, so you don't like miss out on that. All right, now we have store devices, restore devices. Right, so this is when we sort of save the state of the devices to like persistent data here. So let's copy this. Because this is just, yeah, this is device type, that's right. Now we don't have a property initially on, so we cannot use that. Is activated. That is if the state is not idle. We could use that thing. Okay. Oh, I don't know why that's not. I'm not getting LSP for that. But anyway, is activated. And then we have should save state if. I mean, I guess this is going to be always if it's activated, because this type of device is like, if it's activated, then it's gone. If you save and come back, it's going to be gone. So, and there's no point in having that initial state being activated for this, because then it's just not there at all. So we probably always want to save it if it has been activated. We should save the state of that. Right, and now we also need a new list of things here. Explosive walls. And this feels like it could be generalized, but I don't feel like we have enough data points yet to make some sort of generalization. I mean, you can see what we're doing here. This is the state that we save in the persistent data. So for all devices, it basically only saves the state. That's the only thing we're worried about. And the state is just an enum of what state it's in. So that's the only thing. But it could be something in the future where you save like actual numbers or something. I don't know. But this is, but that could be part of the state. So, but yeah. Anyway, let's see. This should now be explosive walls, and this is explosive wall, and this one is, yeah. This part should definitely be able to be generalized here. Should save state. So if we should save the state, we just save the state here. We create the entry, we save the state, or we populate it with the state here. If we don't need to have this, I mean, should save state basically means if we need to keep a new state around that is different from the initial state, from like when you start the game from the first time. So if it's different, then we store it in the persistent data. If it's not different, then we don't need to, we don't need to store it because it's the same as the initial data. So we can just remove that thing from the map. So this part could be technically sort of generalized because we're sort of repeating the same thing here for all. We have 3 different types of devices right now. But we're probably gonna have more later. I guess this is a little bit different here because it's checking. Well, it is the thing that is the same is what is the new state to be saved, and where is it going to be put? Like which map is it going to be put, and is it going to be saved or is it going to be removed? Those 3 things are common between these 3. But anyway, it's not that big of a deal to just add it here anyway. So here as well. Oh yeah, we need this one there, and what else here? Yeah, so this one is also pretty straightforward. Very a lot of copy paste, but explosive wall, explosive walls. Oops. All right. Same thing here. Actually, wait. No, that's the same thing. Okay, cool. Explosive walls.toggles. No. There we go. But it also is kind of nice when you have a system in place and when you extend it, it's not hugely difficult. So that's nice. And then over time you can see sort of similarities and where you can sort of where you see here that okay, we have these things 3 times now, maybe there's some way to fix it, but I think we'll wait a little bit more since it's so easy to just add new things. And it's also very discoverable. Like I didn't remember all these places, but the compiler basically told me, hey, you need to add this here, you need to add this here, you need to add this here. So that is a very nice thing about this whole setup as well. Alright, so now we should actually see this thing being spawned actually. So fingers crossed if we actually gonna if it's actually gonna not crash, but we'll see. And also technically it should play the animation when it's activated as well. There we go. Except it's like behind, but we can fix that. We can fix it. Let's see. So these two need to be in the background and not in the foreground. So we'll copy, we'll take these two out, put it in the background. There, save, go back over here. There we go. Now it's in the front. Okay, so here's our activation thing. We'll activate it and nothing happens. Okay. Wait, it might be the hitbox that's weird. I mean, you can see the hitbox is kind of nice actually. I can kind of go into it like this. Okay, so I'm not sure why it doesn't activate, so let's figure that out. Because we did copy basically everything that is to do with toggles, and the toggle does activate when you shoot the beam on it. So let's go to devices and oh wait, I updated. I kind of okay. Yeah, so actually I copied the door function. I did not copy this part here. So we probably want to move this into a function here, because we basically want to check, okay, is the lens beam hitting us? We should be the same for all these entities. So probably we just want a bool function that checks this and returns true at this point here instead of activating it. Yeah. So we'll take this out and we'll add a function somewhere. Is hit by lens beam. All right. We need the entity there. Let's see, is that all we need? Device type, right. Like that. All right. So now basically we just check, okay, if is hit by lens beam, then device type dot activate, and then this one will say, okay, if we're hit, we will return true. Let's just remove this from pseudocode that I had before. So we'll return true there and false otherwise. There we go. Is there anything we need to get rid of here? I don't think so. The iterator is... Don't need to deinitialize that. Alright. So now we can just very easily check this. And... here we're saying, okay, if the explosive wall hit by lens beam, we activate it. Right. And that should be fine. Actually, this would be a bit weird. So because if we wait, what's happening here? Is this a bug here? Like, let's say we activate it, we hit it at the we hit it. Then we check, okay, it is activated, but the animation is still not changed to the new animation, so it's idle. So the animation should be done, which immediately said it's to destroy because this function will return true. So we're probably gonna check this first and then say hit, or we only allow this when we're idle. Actually, yeah. That makes a lot of sense. We'll just put that in there, like if it's hit, then we activate it. What? Oh, I don't even need this. Okay. There we go. All right, cool. So if it's idle, we're checking if it's hit by the lens beam. If it is, we activate it. If it's activated, we check if the animation instance is done. If it is, we set it to destroyed. If it's destroyed, we don't do anything. Right. Oh wait. I need to start here. Oh, it started up the game in the wrong way. Okay, there we go. Now I will check if it gets activated. There we go. So there you can see, and it actually got destroyed, but it didn't destroy the sort of wall behind here. But yeah, we'll fix that. But that's really nice. We got the thing pretty easily added here and set up. So let's see. So next thing I think would be to destroy the tiles around it. So I'm thinking just as a main rule that it's gonna destroy the tiles that it's on, so to speak. Like it's gonna have a special place where the tiles actually are. So we're gonna be able to calculate which tiles we'll need to destroy. Now the problem remains, however, how to actually destroy the tiles themselves. So that's going to be the next step here. So yeah. Hello Phoenix, how's it going? Hola. Yeah, so that is something that I haven't done before, so that's gonna be interesting. We're gonna need some way of saving that state as well. Saving, I mean, either we save, so either we can do weird, like a super sort of dynamic system, or maybe not dynamic, but a super sort of a system where we could basically define any tile to be destroyed or whatever. But we could also sort of hard code in that, okay, if we encounter a wall that has been destroyed, we'll just clean it up right away every time we load in the level. What is device type? Device type is a type of device. It is this one. So we have like a bunch of different types of devices that you can sort of activate. It's like something that you can activate, I guess you could say. Like buttons, doors, and yeah, we just added this one here, explosive wall, to remove a wall. Although maybe we just don't have the tile there at all. That could also be a thing, because it kind of covers the background anyway. So we could just remove these. And this one could be, I guess it could just be there, whatever. Okay, so now we have destructible walls. Except we need to add a little bit more like flair to it, I guess. But let's do that. Let's spawn a bunch of explosions here. Are you a developer, Phoenix? A lot of times I read C code, it looks similar to Rust, which is a lot of similar to C++, which makes me sad. Okay. You read C code, it looks similar to Rust, which is similar to C++. So are you a C++ developer, or how should I interpret that? Or... where did I want to go? Big fan of C Odin. Wait, I think did we speak before? I think I talked to someone who started to look into Odin. And yeah. Welcome back. Sorry I didn't remember, but I don't have the greatest memory when it comes to like nicks and stuff. So well, I mean, if Odin, let's say Odin is a better C, let's say, but does it feel different? Because I feel like SIG feels different as well. It's like, yes, it's low level, and yes, it shares a lot of similarities, but it's also its own thing as well, it feels like. So it has a different sort of feel to it, I believe. Or that's how I feel right now, actually. But I mean, granted, I haven't actually programmed in C that much, but or Odin for that matter. I have programmed in C++, but that was a long time ago. And it's gotten way more sort of functional, as I understand it, from when I first started. Wait, where did I want to go? So, wait, what did we do? So, we destroyed the wall, right? Also, this wall, that should be destroyed already with this. Whoops. The wall should not come back. It should be destroyed. I mean, I guess it's fine now because we want to try test it, but it should actually be, it should be sort of, it should be saved in the save file. Oops. There we go. So it doesn't save it here. Oh, I forgot. I think I forgot to add it to the function here. Oh, yeah. Maybe I should automate this. So this is the cool thing here. You can automate if you have a struct. I'm not sure if you know this, but if you have a struct, which is this one is a struct here, and you have a bunch of fields that are basically the same thing. What you could do is you can automate a lot of these things. Actually, you can generalize this entire struct if you want with these sort of generic things. If it has the same pattern, you could really automate this. But I mean, this one is an easy example. Let's do it here. So you can do 4, actually inline 4, and then just there's a package called meta fields, or a package is like a built-in thing. So you go fields and then this, which is the struct type. Okay, and then we get a field out there, and then we can just call. So this looks a bit weird, but it's like it works. So we will access this field, and we will call the initialize on that with the allocator. So that's basically the same thing. This is gonna expand into this, but you don't need to keep adding lines, which is the point here. So you can loop through all the fields, and this is basically like a macro almost, or like yeah, you're generating code basically. So this is going to expand into this here, which is it's nice if you know what, like if you see this and you know how to read it, it's really good, because then you can just, okay, oh yeah, I understand what's happening. But if you don't know about comp time and this stuff here, then it's just going to be like, what the hell is going on here? But yeah, that's like a SIG thing here. So yeah, and now we can just remove these, and we can do the same thing over here, where we can say inline 4, and instead of doing this, we're gonna do try write array map writer, and then the map is gonna be this part dot map. Now granted, this also means that you have to keep to the same pattern, of course. So if you have another field that doesn't conform to this is going to be all of a sudden it's going to be an issue. However, if you keep to the same pattern, then you don't need to add more lines here. So it's all automated here. And if you really want to guard yourself, you can do this. You can say, okay, should only consist of fields that are ID array hash maps. Okay. Oops, what the hell? So and then another thing, like you could also automate. Technically, you could automate this as well, like looking through all the devices, the device types, and automate like grabbing the state from some common type of pattern, and you do that as well. But but that's going a little bit overboard here. But I do like this. I do like just if we keep to the same pattern, we can just more easily add these things here. I found stuff like that pretty unnecessary. When you iterate, you should remove as much friction as possible instead of confirm into something that might turn into a trap. Because how confident will you be that you stick to the pattern? I mean, yeah, and that's why I wanted to add a little bit of guardrail, and that's also the thing here. Like, if you you're gonna notice if you're trying to do something else, and that's gonna be that. Then you have to like rethink how you want to do it. But so if I, for example, if I add something else here, if I add a bool here, then that's gonna be caught in a compiler here. So you can see here that okay, we get a thing, no field of memory function called init and bool. And I mean technically we could also have a guardrail. You could build in guardrails. So you could say com time, and you could check. You could check here. You could add a thing that checks for the type. So you could say you could get the fields, and then you can say okay, if the field type if it doesn't conform to this pattern, then you know, if you really want to build in super guardrails, you can do it. So if the now this is a generic type, so it's gonna be a bit tricky, I think. Maybe. I guess what you could do is you could say if has declaration. Actually, what you could do here, you could do if field if has declaration be initialized, then we call it initialize. So then you don't get the error. But technically, you could put in all sorts of guardrails for this as well if you want. Just write the code and still unhandy and rethink it, and once you solve the problem, yeah. So that's also that. I mean, this is just an example. It's just yeah. This is because the thing is that this pattern that I have is basically right now. I just added a new case to this pattern, and it was the third case. And I said before that it's not enough for me to actually start to generalize full on 100% go ham and generalize everything about this. But it is starting to emerge a pattern here, and what I was saying is that it's nice that you can actually, if you have this pattern, you can sort of generalize it with this type of things here, instead of and then it becomes very easy to just add new things. But you have to be careful in those cases where, okay, if you add something that doesn't conform to a pattern, then all of a sudden all hell breaks loose if you have all these sort of things in place where you can do that. But you can do this. You can also put in all sorts of guardrails for whatever thing is here. Let's say you want to add a different type of map that doesn't have the exact same structure that the previous ones has or anything like that. Maybe you need to access it in another way, and then it becomes cumbersome all of a sudden. So oh yeah, this is even becoming a problem here. So you have to like check if it's a bool, like type info. I'm just showing what you could do with this system. This is just an example for this sort of case. Like so far, this is keeping to the pattern, So I think I am actually going to have it like this, but it's so easy to fix if it turns out it's a different thing. So I'm just gonna keep it like this for now. Yeah. Anyway, what's this? Use size don't support field access. Okay, let's save and see. Oh yeah, this is, wait, this is not self, it's gonna be self.devices. There we go. Wait, what the hell is this? No field name version in save. Oh, also this one is like wrong as well. So we have to grab the type of self devices. There we go. You need to use the correct type and the correct subject there. Okay, now it works. Because the thing is that this, I think I more likely forget to do this than that the pattern is gonna change. So I would rather have this in place to sort of guardrail against me forgetting to add these lines, because I might not notice that it's not there, because right now the bug that it introduced by not having these things was that the new data was not persisted to the save. So we can see this device here is there, and then I activate it, it disappears, and then I go out and I load in and it's still there. So that's the bug, and somehow it's still there. So so why is it still there? I don't know. Is there a reason a lot of the C code looks similar to OP, where it's an object with methods? I guess, I mean, let's see. So the thing is, I'm not that well versed in C, and I know that C is basically structs with functions. So, but probably more like structs are just the data, and then you have a bunch of functions that is doing the work. So in SIG, it's like, I think it's very much encouraged to have functions on the structs themselves to do things. And I can understand both ways, you know. I mean, using functions on data is more like I see that as more like a functional approach, actually. Well, it aligns a lot with the functional approach, while having an object that you can access functions on is like, I mean, to me it's just one tool in the toolbox of a programmer. So if you're used, and I think that you should use if you're working for yourself, for your own project, you should use the tools that you know, and of course you can learn new things, but I feel like to be effective, it's also a point where, okay, if I do it my way and I feel it works for me, and then I can keep doing that. However, of course, you can still learn new things and see better ways to do it. But I've learned to do both ways. Like, for example, in JavaScript, where it was very much encouraged at a certain point to use classes instead of just functions, and I guess those old style objects with functions on them and stuff. And instead of doing that, I opted to use just objects and then functions on with that took those types. But I mean, there's no really difference here. Like the functions in here could be used standalone as well, actually. So let's say we have a function here, this save function. You don't have to have a save. I mean, you have to have a save object, I guess, to use it, but you don't have to say save.save to actually use the function. You can use it separately as well and just pass in a save object as well. I mean, Yeah, but then it's the whole how do you structure, how you actually structure the data is a whole other topic. But please, yeah, sure. I'm interested. If you can, I was just trying to explain sort of my reasoning behind doing what I'm doing here. But if you notice anything that could be improved, that is awesome. If you could tell me. Let's see. Struct name, function name, struct name instead of x.f, so you prefix it with a struct if you want an object. So are you saying, like, instead of having functions on the object or on the struct, you would have a function, let's say, I'm just gonna call it save like this for now. And then then you have save, and then you take a save like this. Okay, now so a lot of saves here, but okay, let's just say. Well, okay, I understand. So, well, I'm not sure if I liked it actually. I mean, to me, there's really no difference. Because the thing is here that SIG allows you to access the save function anyway. You can say save.save, and let's say we have a save one here, which is a save struct. Let's just pretend this is a save here. You can actually pass it in like this, so you can still use the same pattern that you're proposing, I think, if I'm understanding this correctly. However, it's sort of built in to the system or to the language. So you can say save.save. We access it. Now you're accessing the actual function here, and you can call it save and then some file name here. So you can do this. And if you want it to be mutable, you have to pass in a pointer like this, and yeah, as well. And let's say it's mutable like this. You can just pass in the pointer or the reference here. Or I guess the address or whatever. So to me, this is sort of the same thing. I don't know if you feel otherwise. SIG basically does what traits in Rust do. Not exactly. I wouldn't say it does the same thing. I mean, because the SIG functions, they only work on this struct. Like, we can't. I mean, you can't pass in another struct here. You have to put in a save there. And while a trait is something that can be like a function that can be used on many different types, that you can define. So it's basically like type classes in Haskell, which I'm familiar with. So except type classes have more powerful. It can do more things than traits can. Yeah, in Haskell you don't have to have like a value that you have to use it on. In Haskell you can just use types to choose the implementation and stuff. But in Rust, yeah, it's like because in Zig there's no such thing. There's no construct of traits. However, you can sort of simulate it. I mean, the power of the comp time stuff can actually go pretty far, but it's pretty cumbersome. But let's say you can sort of have interfaces, like let's say, I mean, if let's say I have a function here called deinitialize, let's say, and we'll take in some sort of object here, which is any type. So you could put in any type, which means it can be anything, which is, I'm gonna say, it's sort of like templating in C++, I would say, almost. Because it's gonna, I think behind the scenes it's gonna like generate a version for each one. I'm actually not sure about that, so I'm actually talking out of my ass, but I'm just thinking about how they actually implemented it. But you can have a function that takes this, any type, and it can be, it doesn't have to be a pointer, it can be anything, it can be a constant or whatever. But if you just call the initialize like this, when you compile this, the compiler will check, okay, when are you calling this function? Let's say we call it over here, init on save 1, let's say. It will actually now even the LSP knows here that it's a save actually. So that I was surprised by that, but it knows that it's a save now because we call the initialize with save, so it like sort of instantiates this function with save here. But you can also call it on other things, so you can call it on whatever you have here, like false, which doesn't have a deinitialize function. But the point is that you can sort of use this as a trait or as a interface or whatever that you can call on anything. So, and I'm using that a little bit in the project where I want to sort of generalize things. We can look at the device type system actually, because that sort of uses. So we have this device type, which is a tagged union. So it's a union, so it can be either of these types here. Now all of these types share some sort of common functionality, which is the functions that I sort of defined down here. So we have get hitbox, we have get animation and stuff, which does a bunch of different things. And for example, for get hitbox, we simply look at, okay, which type are we? We're going into the subtype that we have matched with using the tag for the tagged union here. And so then we simply call get hitbox, and that just works because the compiler knows which type it is, and it works. At this point here, S is like compile time known to be which type it is here at this point. So you can just call get hitbox. So it's almost like having what you call it. It's almost like inheritance actually at this point, because you're sort of looking up here in a sort of virtual table, you could say, almost. But it's not really a virtual table because the runtime, that the type is always, it's not. Well, okay. Well, you can't put a value of this type and call get hitbox, and then it will know which type it is. Yeah, it is like a V table because, but it's like one of these enum types here. These three labels are being put into an enum. It's actually the same thing as this. Let's say we have this, let's call it tag. This is an enum. We put these things here, this, and then you can even put it there. So this is the same thing. So you will get this enum here, and based on which enum it is, it will choose a different implementation. So I would say it is very similar to like a virtual table or whatever. But then this is automated, so you don't have to type it out like this. You can just have it like this, and you will still have this enum behind the scenes at this point here. So, and then the nice thing is that you can pass around this type, the device type, and you can still have this generic functionality, which is the point of all this, to have generic functionality that is supposed to be on all of these different things. And of course, the thing that we talked about, like if something doesn't fit the pattern, then it's a problem and you have to rethink a little bit. However, I don't think that there's a huge issue if it doesn't fit 100%. Like let's say deactivate doesn't make sense for one of the devices, which it doesn't make sense for the explosive wall, because explosive wall is just activated once and then it dies. But then we just say that, okay, but nothing happens when we deactivate. So that's like, it's like, okay, it doesn't fit the pattern 100%, but it does fit the pattern because we can just say that nothing's happening when you deactivate. So and the things that need to be sort of super specific, that is not even part of this thing here. So that is handled outside in a system struct, which is down here. So we have this device system. So here we have like functions here that handle specific things for toggle, door, and everything. So toggle is like a thing that you can hit with an activation beam, and then you activate it. Why do you need an activate method? Can't you just change the data? Well, it's to have different things happening depending on what type it is. I mean, yeah, I could technically I could just say here, I could say whatever implementation it needs to be, but it's just, that's just a detail of implementation, I would say. It's just like, let's say we go in here and we go to toggle device activate. So this one, we could do this, sure. We could do whatever it is. This here. So this would be, well, this would be, now we have to say device type of toggle and device type. So we could do this. I mean, sure, and sometimes that's more readable, but it's like I don't know. It's just the implementation detail. It's not really that big of a deal to me. It's like, yeah, it's always like this when you read new code. You know, you read new code, you wish that everything was spelled out at first, but then when you start to learn the system and you realize, okay, well, maybe it's fine to be like this, and maybe it's good. Also, when that's like also like a classic problem. Like, let's say you go to someone else's project, or not even that. I mean, let's say you get hired and you start work on some project, and you see that, okay, this looks like shit or something. You feel like, okay, I have to fix this because this looks like shit, and then you start to work on it, and then you realize that you stumble into the same issues that the other person probably did while doing it, and then you come up to the same solution that person did before. so now you have this shitty state, and that's just because the requirements are convoluted, not the and the expression in the code does not really fit the requirements, I guess you could say. But yeah, so yeah, I mean, technically we don't really need an activate function, but it's also, and we the thing is, it is nice to have this activate. I would say this: it is nice to have the activate function or generic functions when you have a generic way of dealing with it. So let's say, for example, the get animation is a generic function, and we also use it in a generic way. which is when it has its strength, because then we cut a whole lot of logic out. So we'll go to device and we'll say, okay, we have get animation. Where are we actually using it? Well, we're using it in this function, update animation. So it's very simple. It just sets the animation to the current animation based on the state of the device, and also the looping boolean as well. So this now is used in a very generic way, and we don't need this part of the code. We don't need to repeat over and over again, and we don't even need to call update animation over and over again. We just call it from one place now, or maybe two places here. Yeah. Doesn't that code just toggle it? Are you talking about the toggle, device toggle? This activation here? Yes, it is. It is toggling the state, but the state itself, the state is just an enum here. And technically, you could actually implement a toggle function like this, but I think that's just it. I mean, fine. That could be a nice thing to have. And then it's just like if self is on, self is off, else self is off. Right. This is the same thing. I mean, it's I guess it's like. Actually, no. Let's just return a new state instead. Let's just return this instead. I mean, then toggle doesn't really mix. I mean, toggle implies that you actually modify the value, but yeah. So yeah, I mean, but that's just, you know, I think that's just going overboard a little bit. This is basically implementing the toggle action here. Yeah, it is a toggle device. Yeah. So yeah, it is very simple, and that's what it's doing here. And then once the state is changed here, we have a flag that says the state has changed, and then the actual handling that is going to happen because of this state change is actually happening in the system here. So we have this update functions run every frame, and here we handle, here's a generic function that handles all state change of all device types. So we just call this here, and it will handle the state change, but it is then specific to the device type. But there are a bunch of generic things happening here. So we're checking if there has so this is a generic function. It checks because every device type implements the state, or has state changed. So we check that here. Okay. We also have an end off, which just sets. I mean, it just sets has changed states to false, so we can redo it next turn, or I mean next frame. And then we update animation. So that is also very generic. It happens for all different device types here. But then there's specific code here. So here's the specific code, and I should really move this into functions, but right now I haven't done that. But so yeah, there's like a mix of generic code and specific code, and yeah, I'm just using whatever I feel makes sense in the moment, and I'm not trying to perfect it either. I'm not trying to, you know, spend a whole bunch of time trying to get the perfect pattern and stuff like that. I'm just trying to expand when I see problems arise, when I see patterns emerge, and see that, okay, this is actually a pattern, let's make it into a pattern and refactor it and make it look nice and a lot more readable and a lot more terse If I see problems arise, we have to deal with it over time and stuff. So yeah, I'm really trying to, because I really had a problem before where I tried to like prematurely optimize, prematurely refactor the code over and over again until it's like, what's the point, you know? I mean, yeah. So before you even know what the pattern is, you know, you shouldn't do anything. But yeah, so but yeah, let's continue. So the device here did not actually. Oh, I'm getting. Do I have a compiler error here? Oh, wait. I changed this here. That's also a very nice thing, and I'm not sure. I'm pretty sure. I mean, Odin should do this as well. I don't know Odin, so, but and I'm not sure if C has like a linter that does this or whatever. But Zig has like built-in. That as you see here, we put in a pointer, or we changed this to be pointer, which basically means it's mutable now. But then it has guards that, where is it? Here. So it says expected type pointer save found pointer to a const save. So this type is a const. So it shouldn't be changed. To have like guard rails over this type, like let's say, so save here takes a mutable save. That's the difference. It takes a mutable save, but if you call it with a constant, it's gonna be an error because the constant is not supposed to change. Now I'm trying to think what the equivalent would be in C. So it's basically, I mean, it's basically you, because the thing is, I'm pretty sure in C you can't. Is that correct? You can't have constant or a pointer to a constant like this, because now this means that okay, we need a pointer, but the contents of the pointer should be immutable, or it should be constant. And actually now this is not an error anymore because this is a constant and you can just call save on it like this. Sig will actually handle, like if you call this with a local copy, it will actually make it like into a constant pointer, I guess, or a pointer to a constant. Okay, sorry, I'm not sure if I explained this. I'm trying to show a thing here. Because, yeah. And so the thing is, like, let's say we want a pointer to a constant. Now, if we make this mutable, let's say, will that be an error? I don't think so, right? That doesn't make sense to be an error, because it's just saying that I'm not gonna change the value. Yeah, but anyway, that's also very nice. It's a nice guardrail for saying that okay, this function shouldn't change, or it needs to change the value. So you have to put in a pointer here, and then the source of the, like the local copy or whatever, needs to be sent in as a pointer. Let's say, I mean, let's say we do this instead, save.save, and we put save there. Now this is, I think this is going to be an error because well, okay, we'll do save file. There we go. So well, this is not an error because now okay, I'll just fix all this here. Well, okay, so let me explain here. So this parameter takes a constant save. So this parameter is a constant save. It's like having const here, const save. But in SIG you don't write const when you have a parameter like this. But this save const is basically you can't, for example, you cannot now, for example, you can't do this because it's a constant. So this is going to be an error here. Cannot assign to constant. Okay, so that's a constant. So how do we send in something that we want to change? Well, you have to make it into a pointer. But I usually say that, okay, this is now, it makes it mutable, is what I say here. So this is now a mutable parameter that you can change. So now this is not, and this is not an error anymore. Okay. And then, but now here, now this is an error because the save that you put in here is not a pointer, so you have to make it a pointer, right? But it still doesn't work because it says this is a constant. So now we have to make this mutable to make it work. So now, so from const to var, now I say this is a var, so now it's mutable here. Okay, and now everything checks out. But it does guard against, let's say you're using a local copy of something, and then you have to understand that you have to sort of delve a little bit into the stack and heap and stuff like that to make it, to sort of, it sort of guards a little bit against errors happening of that type. And also understanding that, okay, this function will actually mutate the value, so you have to put in something that can be mutated. Yeah. So basically, yeah. So basically, I'm using constants for everything until I know that, okay, now it should be mutable, so I change it into mutable. And also here, like we take in self, which is a pointer to save, but it doesn't look like we're mutating anything here, but we actually are, because this also takes a pointer. So if you call something on self that has, which also plays a little bit into the thing. Well, never mind. Since the thing that you're calling here relies on self being a pointer, then this needs to be a pointer. I mean, this needs to be a pointer, but it is sort of like a pointer, which SIG sort of handles the conversion to a pointer here automatically. So so that does work here. Yeah. Okay. So, but the question still remains why this is not saved. You can see here now we get, this is the printout of the save file. We get a new map here, which is the explosive walls map thing, and it doesn't, it isn't saved, so I'm not sure why. If you try to activate this now, come on. All right, now it's destroyed. So if I exit and we will read this again, it doesn't save it properly. Okay, so store devices. Alright, if it's not idle, then it should be saved. We put it in the map and we set the state to, well, I guess this is actually gonna be destroyed. Otherwise we remove. So I'm not sure why it's not setting it here. Because it's clearly being spawned and everything, and it has state. The state is being changed. It is a device type, otherwise nothing would work here. And once we press quit here, okay, let's check the logs actually. There might be something. No? Okay. Temp save. But since I feel like since SIG has a lot of overlap with C, it would be nice to sort of gain some knowledge of C programming as well, like because I feel like it is sort of leaning more towards the old style of procedural type programming than the sort of C++ things happening. So that is I feel like that's true, but so it would be cool to get more of that knowledge in, like ancient C knowledge. I don't know, but because I'm not that well versed in C. I mean, yeah. And then sort of, okay, what can I take from that and apply to here? Is my thought process there. And maybe even Odin, like looking at Odin and seeing, okay, because sometimes you really just want to say, okay, what's the simplest way of implementing this thing? And then you're just, maybe there's like a super simple way. And that's probably one of the best ways to do it. But then it's always the case that when a project grows and grows, it's gonna be like you can't always do things the simplest way. I feel it's like, or I mean, it always grows into something that is unmanageable if you don't take care of it. If you don't do maintenance and stuff. But that said, why is this not working? So let's just double check everything. We have explosive wall. We see that it is not idle. Then it's activated. If it's activated, we should save the state. Yes. Devices, explosive walls, map getter, put enter the ID. Yes, and then we populate it with being destroyed. So it should be destroyed at the next. It should be saved as being destroyed. If it's not activated, then we don't store it at all. So we remove it if it exists. Right. I mean, I guess we can just see if we get here. And let's also put the state here. Odin is almost a subset of C. Are you saying it has less features? I mean, I guess that could be good. Of like removing features that is like ancient voodoo stuff. Wait, we got here. No, we didn't get here. Okay. Okay, so we didn't get there. Well, that explains some things. Oh, okay, I see what's happening. So the device gets removed as an entity, which means it doesn't even exist in the list of entities. Oh. Right, so because we're iterating through all entities, and it doesn't exist, then it doesn't get saved. Right. Okay. I mean, what we could do is maybe. Well, what we could do is not destroy it. We could keep it around, except we just disable. We just remove. We can basically just remove the rigid body, and yeah. Let's do that. Where is it? Here. Destroyed. We don't mark it for death. What we do is we say remove rigid body from you. Yeah, that should be it actually. Actually, no, we're using the physics system. So physics system. Remove body. Yeah. So this one removes it from the containers, body container, collision groups. Yeah. All right. Okay. So now it should still exist. Where is it? Over here. Okay. But we should be able to also walk through it. There we go. We exit. We check the save file. No, still. Huh. Well, okay, did we get there though? No? No? Okay. What I mean is hardcore C people write their own layers because C has a lot of missing things out of the box. So you have to create, so you have you have to create your own layer. For example, not dealing with null terminated strings, adding slices, etc. Owning was made because Bill wasn't happy enough with that. When I say layer, I mean personalized library. Oh, okay. Yeah, but also, like, you know, if you look back in the day, people probably didn't even like. So when I first learned C++, and I don't know how the professional people worked back then, but it was like a long time ago. It was decades ago. Then it was like, okay, just use stir and compare instead of stir compare, because then you get safety. For example, that's just an example, you know, because that doesn't. I mean, yeah, you just used whatever tools you had, and you could. I mean, you could, of course, write your own library and stuff, but I think over time, as new sort of emergent patterns has evolved and been proven to be just better for, I mean, I guess mostly for what is it, the like, if you wanna, yeah, if your goal is to have a readable code that is reasonably optimized and easy, more like more easier to develop in, and also less prone to bugs and stuff, more emergent patterns that has evolved over time will help with that. And I feel like slices, that was like, I don't think that existed at some point. That did not exist and stuff. So it's like it feels like, yeah, it has a lot of missing things out of the box, yeah. But that's also, yeah, libraries. I'm not sure. I don't know about C, but it's like there are libraries for things as well, you know. But I don't know. Hardcore C people. Okay, yeah. Yeah. So. It was I would say like C was like a ripe. It was like a ripe ground for a new, refreshing, a new language. It just felt like, okay, because you have Rust, you have Zig, you have Odin, you have probably have other stuff as well. I haven't looked into other, like, you have, I don't know, Carbon. Like recently there has been a lot of new languages that tries to reinvent that type of programming language, I feel like. Well, a lot of languages try to add every language feature ever. I would say Zig is not trying to do that. I would say Zig is actually actively trying to not add features to the language, as well as adding features that is like sort of seen as the Zig way of doing things. I feel like there is some sort of arcane path that is being taken to decide which features are going to be added or not added. because I've seen a lot of discussions about, oh, couldn't we add this, couldn't we add this, and then it gets shut down because no, that's not what we want in the language. However, I mean, if you look at C++, I feel like that's, I guess, jokingly or traditionally seen as a language that has like everything. I was actually thinking about this the other day, like, what if there was a language that actually had all paradigms built in? And then of course that is like, as I said, that's like, it's not impossible, but it's not possible to have it seamlessly interact with each other. Because let's say you have I mean, just take functional and imperative, having that world sort of collide, you have to have some sort of entrance and exit into like, what I mean by paradigm is like more like, okay, take for example the program language, the Prolog. Where's that? So you have like a rule-based system that, you know, it does its thing somehow, and you produce some sort of result. But then there's also like a state that you can ask for more results and stuff like that. So it's not necessarily fitting into just an imperative program. I mean, of course, you could say, okay, let's you could use iterators or whatever, or generators or something like that. So that was what I mean by paradigm, like functional, imperative, those kind of rule-based programming languages, stack-based programming languages, all different kinds of things like that. There's no language that has everything as like sort of native to the language, if you see what I'm saying. Like having like built-in syntax for defining all those things, or at least from what I've seen. I mean, I know there's some languages that you can define your own syntax, of course. I mean, in Haskell, even in Haskell, you can sort of define your own syntax as well. I mean, I guess Rust also has that with macros. Haskell has like template Haskell. Wait, what other? I think Ruby also had something to that effect. I'm not sure. I've never used Ruby actually, but I heard that it had some. You could define your own syntax and stuff. So maybe technically you could encode it in, but it's not. I guess it's not like first class supported into the compiler. Something like F#. It is functional programming. You can mutate. You need OOP for .NET compatibility. Yeah, I'm not that well versed in F# as well. I've just used it like once or twice just to try it out. It did not feel very good. But because I was so super confused, like, what is this? Is it functional? What am I doing here? Is it functional or is it imperative? It can be written procedural, yeah. If you do mutable, yeah. Yeah, I don't know. I came in it with, you know, knowledge about imperative and functional and stuff, but I couldn't figure out like how to think in F#. But I didn't try for long, but and I didn't use any tutorials or anything, but I was just trying to explore it by myself. But it was very interesting because it's like very close to C# and OP, because then in my job then technically, you know, or in my realm, you know, web development, I haven't seen it a lot. I have seen it sometimes. People use F#, but it's just like, okay, it's been used for like configurations or something like that. I don't know. I've never actually dealt with it, so. But yeah, I mean, technically Haskell is. You can also write imperative code in Haskell. It's just that it's actually functional programming. Like under the hood. I prefer reading F# over C#. Yeah, I prefer reading, if it's not too complicated, I prefer reading functional code. Because it's just more, it just says what it is. It's more declarative. But then if you really, the problem comes when you really want to know, okay, what is going on under the hood? How is this actually working? If you need to fix something, or you need to sort of go around and hunt down places where you don't know where is this code executed, how is it executed, etc. But why is this not working? Oh, it's just straight up destroying the entity. What the hell? That's not correct. Okay, I need to fix that. So I need to actually go over to the other project here. Yeah, we're not supposed to destroy it. We're just supposed to remove the rigid body. Okay. Moving rigid body does not destroy entity. Okay, I'm just to make sure nothing gets leaked here, I'm just gonna do this. Alright. Okay, so now that is pushed. Great. Now we go back and we say no. Fetch. There we go. Okay. Where are we? We were in here. Or here. Alright. I'm just gonna do this so we get correct LSP context here. Alright. Now this should no longer remove or destroy the entity. However, this also means that whatever we do this otherwise, it's actually destroying the entity. So okay, let's just do this here. Okay, fine. So it's not actually being used anywhere else. Okay. So now, just to make sure, we open up this, we read so CBOR. There we go. So this map is empty. Right. So now we try this again. And it's compiling, I think. There we are. Now let's activate it. Oh, it's crashing. Interesting. Unreachable code. Okay. Oh man. Okay, so if I'm just explaining what's going on, so the ECS, well, so let's see. Here we're removing the rigid body, right? So it should just be so this one actually removes the component here from the ECS system. Okay. So it shouldn't be in the component system, or it shouldn't be in the ECS system anymore. All right. Now, if we go to draw, where the thing said it was, which line is this? 105. We have this here, body equals this. Okay, but why are we? So why are we getting this entity? Oh yeah, man, this is old. This is very old code here. Well, I shouldn't modify this. This is like in a cache. I guess it doesn't really matter, but so we're filtering items based on this function. Which thing are we actually filtering on? Source and destination. Okay, this is the source. Storage data. Oh, the layer view. This is just draw layer component. Ah, we need to remove draw layer component. I mean, we could do that. We could. What we also could do is we could say. Wait. We could say. If we could say try get, I think, or maybe not. Can we? Is there like a has? No. I mean, we could just do this as well. Try get. That's the same thing. And then if we don't have one, we can just continue. So that is how we could solve it. But another way, because we don't need, like, modify this would be to go back to wherever we was, over here somewhere, here, and we also remove, I guess, the draw stuff as well. Actually, we could also do, we could just add invisible. Yeah. How is ECS going for you? I like it. I mean, I feel like it's really versatile. Like, I am using a mixed system where some components are used very generically. You know, it's like it has its system, it has its component, and it works pretty good. But for the things that I feel like, okay, yeah, this is very, it makes sense, it fits very nice into this pattern. But for others components that I was kind of like, okay, I'm not sure exactly how to implement this part, so I'm just gonna implement a component that has a bunch of functionality in it. So it has a bunch of different things in it. Like, for example, I can show you, well, if we go to components, very simple component, let's see. Well, I guess health is sort of very simple. It has health, max health. We also have like pending damage that is sort of used as a way for monsters to deal damage or you to deal damage, and then it gets like negated at the step where we actually check for health and stuff like that. We have invincibility duration as well, so you can be invincible. So I mean, it's sort of simple, but it also has these. I mean, these two are like a given for a health component, but these two maybe you can do in different ways or something like that. But anyway, so very simple here, and then we have a health system that is checking for pending damage. So it's iterating through all the health components. Or I mean, it's iterating through all entities that has health components and that doesn't have death component, because if it has death component, that is basically it's dying or it's dead, or yeah. So it doesn't really, we don't care about health for those. But for everyone else that has a health component, we just care about health components. We don't care about anything else. We just handle a bunch of things here. Okay, but so that's very simple for the health. But then let's say when I sort of think about monster AI, I actually, that was way harder for me to figure out. So what I did was, well, now we have different types of monsters as well. But what I do was I created this sort of monster AI component it more looks like the game object type architecture, where you have one structure that has a whole bunch of stuff in it, and then a whole bunch of logic that goes with it. So this is I'm kind of mixing the architectures a little bit, and maybe it makes sense to move some stuff out as components, but I haven't really gotten to the point where I can see a sort of clear pattern where I can do that, and I'm not actively trying to refine the architecture like that either. So I'm sticking with what I have right now, and if I see something in the future that I need to fix, like if I gain enough from it, I will do it. But so this is more akin to the device type that you saw earlier. We have a bunch of generic functions here, and yeah, the monster AI system has been I mean, I've tried to make it a bit generic here, and it has grown sort of organically from the types of monster that I had to whatever abilities they need to do at certain points in the sort of state chain, or whatever you can call it, behavior or state machine. So we have these sort of generic functions which are called generically, and then we also have specific things called whenever it is. So here, for example, here we have an example of using the comp time stuff. So so if you have a monster type that has this function implemented, we call that, but if we don't have it, we call a generic one instead. So yeah, it's just this project is also me sort of exploring the different possibilities that SIG has. So it's not like what I'm showing here is like, oh, this is like top notch, you know. But it's like I'm exploring, and sometimes it looks like shit, and I'm trying to, you know, find good ways of doing it. I'm exploring things at the same time as I'm like building the project. Now I know that that's not really a good way to build something for the first time, or I mean build let's say I was working for a company. I wouldn't actually choose to do something in Zig. If I weren't proficient in a language, I wouldn't choose that language to start a new project that is going to be used in production, let's say. And for this part, I'm actually treating this as both a thing that I am actually building for myself, but also a way to sort of learn the language and explore the different types of things that you can do. I know a few people tried ECS and instead does this sort of thing. All right. Let's see. See if I can get this up here. Entity structure, megastruct. All right, so Odin, okay. Entity megastruct. This is extremely simple, flexible entity structure for video games that doesn't make you want to die when you're 20k lines deep in a project. You never have to think about ideal entity structure again and can get back to working on things that actually matter, using it to add new entities to make your game better instead of overthinking. Has all the reuse power of our entity component system, doesn't have the complexity of VCS. You don't have to think about where to put that one new piece of data you need while in the middle of gameplay programming. You can do easily serialization by just copying the bytes over. Well, that all sounds very nice. It seems messy and wasteful. Okay, probably won't get you late. All right. If you're heavily memory constrained, you'll probably want to upgrade this into discriminated union with shared entity based structure. At first I was thinking like, okay, do you mean my brain or the actual programmer? Discriminated union with shared entity based structure, okay. Or even dynamically allocate each new entity, but that comes with extra complexity, so don't pay it unless you have to. All right, cool. So a bunch of different games there. Nice. It holds up incredibly well, even as you scale it up. I got this idea from Brian Fleury a few years ago. Been using it to every single day ever since. Well, that seems very, very good. This is Odin style pseudocode and won't actually compare. Oh, that's why it was in Odin here. Okay. There's a few missing pieces and extra things you need to be scaling up, but it's good enough overview to get the point across. The data structures. You can crank this however high you want. In Terrafactor, I actually got mine at 65. Okay. With some extra things for looping over them properly. All right, max entities. Okay. And that is just a straight up array here. Okay. This looks very much like when the first sort of ECS system that I tried to do myself. I just put all the entities in array. But this entity, but entity was I think it was like an ID maybe. This is actually a struct that has a lot of stuff. Okay. Okay, so we have entities. We have the ID thing, counter, ID counter here, top count. What is that? World name. Okay. And the player handle. Okay. So we have different types of entities. Entity kind. Interesting. Entity kind. Could pack this into flags if you like it. So the entity kind of makes me think that, okay, this is a mix then of ECS with sort of not inheritance, but I guess well, I don't know what to call it. Kind of the kind. Has physics, bool, cut packs and flags if you feel like it. Okay. Has physics, damageable player is mob, blocks mobs. Position. So this is this is on every entity. Okay. Const data. Using const data, const entity data. This is constant. So this is just a bunch of, generic stuff. This is constant based on the kind of entity. You could put this somewhere else if you want, like having the inside entity for easy access, using in Odin / Jai specific and makes it you can entity dot max. Okay. It's like using namespace in Zig. Almost. Except this works for fields. Yeah. It looks like, yeah. While in Zig you can't actually get fields like this. So it's like a mixin, almost, you could say. But it actually puts it in the struct, right? Constant data, update, draw. So are these pointers to functions? And then sprite ID, max health. You could move this back to enter struct to make it dynamic. No existing code will break. Okay. Right, because you can move it and it's the same thing. Yeah. You can access it the same way. Creating, destroying, entity create. Alright, so you take a kind, you get an entity out. New index. Look through, entity grad, first one isn't allocated. Alright. You could also use a free list and use straight from entity top count when that's empty. Okay. New entity is something for this. Alright, so here we're finding the thing, okay. And then we don't find a place for it, it's error. We increase the count, we set the allocated flag to true, we populate a bunch of stuff. We depending on what kind, we do different setups. All right. So how do we know which type this is? Is this well, I guess it's this type. Const data. Oh, because it's supposed to be constant. I see. Right. Entity destroy, okay. And that just sets it to this. Alright. Handle. So All right. Handle. Use this for storing entities instead of pointers for any longish period of time. If you're holding a pointer, the thing has a chance to be destroyed. Yes. Yes, that is very true. Index and ID, right? So that just that's on the entity itself. Okay, so you grab the handle like that. Okay. And this is handle to entity. So okay, and then zero entity is like just a marker, or just like a thing that you can check for equality here, because you're returning a pointer and you can just check if it's this pointer here. Okay, cool. Okay, if handle is nothing, then this. Okay, how does this work in? Is it like zero initialized? Does it does Odin, or I guess this is pseudocode, but I'm guessing Odin doesn't like deeply like deep have deep equality here. Or what does this mean? Or is it just pseudocode? Is nil? Okay. So is nil something that every struct can be? Because in Zig that is like explicit. You have to explicitly say something can be null or optional. Which would be the way to do this. Instead of having this, you just return a nullable, or I mean optional pointer. Okay, and then we have an entity which is set to the index of that. Alright, and then we just return that pointer. Otherwise we have the zero entity here. Okay. The entity has been destroyed. Alright, okay. When you get zero entity in return, instead of null pod, you can safely access it, right? But you can't access pointers that is stored on it, right? Because it's like garbage data there. Or I guess it's zeros maybe. It depends on how it's done. Since the entire thing is zeroed, okay, it's zeroed. A lot of the logic arguments with gracefully, okay. Except if you're trying to access a pointer, it's gonna be segfault, right? Handle that is invalid, entity handle. Entity handle. Right. Yeah. I mean, that works. Setup, where the content magic happens. Okay. Setup is designed to write into both main dynamic entity structure and const entity data structure. The way everything you need to add a new piece of content, enemy build item is all localized in one place. This becomes very important for the speed of adding new stuff in. What I usually do is just copy from the most similar existing entity as a starting point. Yeah, I mean, that's similar to what I'm doing when I try to add something. It's just that I have a very specific location for devices. That's where I have the thing. It's localized to that, and then I can just. I want to have a setup where I can easily add new stuff in, and when I do so, if not, the compiler's gonna. I mean, either it's just as simple as just adding it in place, or the compiler's gonna tell me about all the places that I need to modify in order for the thing to actually be implemented. So that's kind of how I have it set up right now. All right, so here, let's see, set up player. But I do understand the importance of having everything in one place, and also if you want to search for the implementation of something, you can easily find it here and search for it. Entity kinds player has physics, health is 100, update is equal to this. Oh, you can actually have you can actually do this. So this is not as easy to do in SIG. It is possible, but you don't get a capture here. I guess you don't do it here either. You pass it in here. Okay, so entity health is, so this is the update function. Okay, sure. Draw, yeah. Goblin, set a bunch of flags, yeah. Static sprite. Okay. 100% fine in early days, just loop through all entities like this. Make it faster later, you actually notice it becomes a problem, not before. Yeah, I agree. I have a bunch of places where I can totally optimize, but there's no point since I've not reached the point where it's actually a problem yet. Alright, and then you just have a while true, I guess, update render. And we're going through all the entities, we're checking if it's allocated, we update it, we check physics, we update the physics. And the entities, what's this? Could do some other stuff, like things go slow inside entity update, break them out and optimize the larger one. Oh, okay. A very incomplete example, just showing off the entity draw. Alright, so, I mean, I see what's happening. So this is basically like a mix of, I wouldn't say this is ECS, of course. I'm not sure if you, I'm pretty sure you didn't say that, but it is, I mean, it is not ECS because you can't, I mean, you could argue, like, you know, abstractly, like, okay, these are components and you can like add this component and remove the component, you know, but yeah, it does work. It does sort of fill the same purpose, I guess. You could, if you just add, okay, we need a new component, just add the data here, and then every entity has access to that component, and run, because it might be enough for your game if you don't want to run a full-on ECS system that is supposed to be working for a lot of things. So yeah, that is I think I really like this, actually. It really looks very, very easy to use, easy to understand, easy to look at. You just say entity dot blah blah blah, and there you go, there you have it, you know, instead of having all these sort of things happening. But in this example, I mean, it shows the architecture very nicely, but it does hide, like, when a project grows, it's not gonna look like this. It's gonna be, you know, that's not a problem with the architecture, I don't think. That's a problem with all projects that exist. It's gonna exist ever. They always gonna have this problem where even if you have the simplest sort of beginning architecture, even like when that grows, it's gonna be, you're gonna have to maintain it. It doesn't separate entities, system, and components. Yeah. And yeah, I mean, it's a really nice like way to do things, and what's nice about it also is like the entity is where all the data is, so you don't need to worry about where the data is, sort of the source of truth, where the data is as well. People like him did easiest for a big game and had a bad time. I see. But I really like the ECS library that I'm using. Actually, it works very well. I mean, I'm really using it as a tool to accomplish my goal. It's like I also like it is a bit different because here we're kind of defining all the data in one place. But if you look at my example here, it's kind of the other way around. Like we define, if you go to the health component, we define this in this file. This is just in this file. So this is just focusing on health. And I think that's also one of the differences, you could say. Like in there, it's like everything is all at once. Here it's like, okay, we have here we only focus on health. Now, granted that when systems sort of overlap, like here we have death, the death system and the health system actually overlap a lot. And so we have a bit of overlap here, but I think it's fine, you know, as long as it's not too complicated. When it gets too complicated, you have to look at it and see, okay, could we make this a bit simpler to do? Maybe even health and death and all that should be one system instead of having separate systems for it. Technically it's slower, but memory is so cheap. Texture assets take up more memory usually. Right. Yeah. I mean, I guess technically for my game I don't really need... If you have a simple sort of 2D game where... Or even... It doesn't need to be 2D, you know, but... A simple game with not that many entities and not that like much complexity, I guess, you know, you could get away with doing it like that. I don't know. I just feel like it's nice to have the views that you iterate through, like. Here we iterate through. I mean, I guess that the equivalent here would be to, instead of having a view where you're iterating through all entities with this component, when without these components, you can just iterate through all entities, which is that is actually exactly how I implemented my first ECS system. I think, or my first ECS system in Zig, I think. So I actually kind of did that. I had entity, it was basically a list of IDs, I think. I forgot which project was that. And then I had, oh, what the fuck, what was I doing? Yeah, I don't remember. But I guess you could check, like, I mean, technically, you could also put the health component as a... You could have, like, let's say you have entity, and you have, like, health is a nullable health component, and then all the other things, and then you would just check, okay, do we have a health component, and this is null, or I mean, if this is null, then we don't have a health component, so we just skip this. If it's not null, then we look into it. But what I think is nice about this ECS system is, like, you get a lot of things, like a lot of functionality there. And yeah, for here example, you create a view where you get all things that has health component and everything that does not have a death component. Or I mean, everything that has a health component but not a death component. And you can iterate through all those entities. And we can just look at the health and deal with, like, the update here. And if I ever need to change anything with the health system, I know where to find it as well. It's like, it is a lot of the things I feel like in programming, when you're working with a project that grows and grows, the biggest problem is not sort of the architecture or the quality of the code or anything like that. It's like organization. It's the organization is the biggest problem I feel for, because that is like, it's like when you're trying to, okay, where should I put this logic, where should I put this new stuff, that is the, sort of the issue that you're gonna get. And I mean, technically you could have everything in one file, but as it says, it's fine to iterate over all entities and optimize if it becomes a real problem. Yeah. Yeah, that is very true. Very true. But this works very well for me. I mean, this library has that all built in, so I don't need to worry about it. I can create new entities very easily. As long as I pass this registry around, I can just create new entities. I can add, remove components at will. I can just, if I want to add, and the components are just structs. They can be anything. So if I want to add a new component, I would just create a new struct, and there we go. There's a new component, and then I can immediately use it, and I can create views with it. I can iterate through all entities that has that component. I can check if an entity has that component. I can remove it, and so on and so forth. So I actually really like this architecture. Like, I really like this library and this architecture. And then you don't actually have to keep the hardcore ECS to use it. You can mix and match, like I have done with the Monster AI system and the other stuff, like stuff that is sort of very generic and fits very well to be generic. That makes a lot of sense to have a component for just that thing and then a system for just that thing. But if I have Monster AI, for example, then I'm now using like more of a, almost like an inheritance pattern. If it becomes painful, just keep the other thing in mind. Yeah, thanks. A really nice example there of architecture. I should probably like test that. I mean, if I'm gonna do a new game which is gonna be like very simple, and you just, I mean, let's say you can start with this as a template, and then once the game becomes, let's say it grows larger and then it becomes like unwieldy, you can then at that point decide to, okay, let's just change the architecture, and see if we can find a better way to do it, because everything is possible, you know. But yeah, really nice example there. I've also been thinking, like, I've sort of aimed to implement this already, but for monsters, for example, having like, they are different types of entities, you could say. So it is sort of like the entity kind that it has, except it's not as simple, you know. But it is sort of stored in a enum here. So these are all the different sort of monster types. So this is like specific for monsters, and exactly like the device types works, but this is for monsters. So these are all the different monsters. It's just an enum. And then there's different settings for each monster, basically. Yeah, so wait, what was the thing that I wanted to say here? Oh yeah. So not only can we use this monster type to determine sort of which logic to use when, but also what components and what data to actually create. So it's sort of like I was thinking when I was thinking more about like ECS systems and how to like improve on just having entity systems and components. Let's say you could sort of mix in a system of inheritance in there if you want. Like, let's say all monsters are gonna share some components, like let's say a physics body, for example. Well, why not just create a group of components that is always gonna be added for those types of things? And that's sort of what I have here. Where is the init function at? We have an init function somewhere. Here's init entity. So this is where the thing is created. Oh, here we go. So we have init monster, which is sort of like a common thing that all monsters are gonna have. So this sort of like a thing that adds all the data needed for all different monsters. So yeah. that's basically it there. And if something needs to be changed, then we can simply take the entity out here, and we can just add another sort of specific component here. But yeah, it is, you know, every project grows in complexity. I don't know. Let's see. Wait, so we did this thing. This still didn't work here. Come on. This still didn't work. Oh yeah, because we got an error here. And what we needed to do was we needed to... Okay, so I'm adding invincible, that's right. So I'm adding invincible, that means it's not gonna be drawn. So that is a kind of a convoluted way of fixing it, but I just want to fix it right now. And that's fine, you know. Sometimes you just want to get it work, and then you can sort of fix it later. If it's not gonna be a super if it's not gonna be something that it has a lot of consequences laid down the line, then it's not, I don't see it as a huge issue. Okay, so now we get this state stored, and if we run again, this should just be gone. No, it's not. Okay. All right, so interesting. Let's see what is happening in registers devices. Right, it should be set to destroyed here. We should get destroyed, and we should set it to destroyed. Okay, and then we're calling handle state change. And we're saying if it's destroyed, we are gonna do these things. So I'm not sure why it's not doing that. Restoring explosive wall. I just want to see if it goes in here where the actual error is happening. Oh, it's idle? Okay, now it's idle. Okay, but if we we're running it. And now it's destroyed. No, not there. Wait. Where is the... No, it's in restore. I don't think code organization has to be anything difficult. One of my favorite articles. I mean, okay. It would be amazing if I mean, I certainly don't feel like that way, but semantic compression. Yeah, I'm not gonna read it. It's too long. But yeah, I'll look into it. It's just I think it's like an inherent problem with large projects. And also it's also an inherent problem with when you're working with teams. Depending on if you have someone that decides how it should be. If you don't, then it's also like a problem as well. And yeah, I don't know. It just feels like that's one of the hurdles that you have to constantly jump through. If you don't, if you're working in a project that is like constantly changing, the patterns is constantly. It doesn't have a set way of doing things. So, and if you're discovering new patterns that you want to have, you know. Explosive wall, yes, I want to go to explosive wall. Let's see, if we load this in, it should log that out. Let's check that. Explosive wall idle, so for some reason it says idle here. Well, okay, I understand. It says idle because that's the default state, so that's not... I guess, yeah, that's not an issue. Okay, but now we have to... Now it's stored as idle again. I can see the teams thing. Conway's law is a very real thing. I forget exactly what that was. But yeah, it is a huge problem. I feel like it's one of the things that makes it take 10 times longer. It's like, yeah, we have a solution. We know exactly how to fix this problem. We can do it really quickly. It's just that we want to make sure that everyone is happy, and we want to make sure that we put it in a place where it's scalable. We want to put it like we want to have like, do we need a pattern for this? Which pattern is it gonna fit in? Sometimes people just don't care about the patterns. They just put stuff outside and that's that. And sometimes that's a good thing if it's just throwaway stuff, or I don't know. It just okay. I'm just gonna check here. Destroyed. Oh, I hate it when I do that. Okay, there we go. Oh wait, did I move this? No, I don't think so. Okay, so if we just exit now and we check the logs again. Oh, we got leaks. Okay, explosive. Oh, I see. That's the other project there. There we go. Explosive wall idle. Wait. Just says it once. Oh. It doesn't find it. Wait, it should find it. Okay, what ID is it putting out? Because we can confirm the ID actually. Eight six. All right. How can we put the wrong ID? That's weird. I'm not printing out the ID. Well, we have it in the scene, which is, wait, which scene is this? Forest and hill entrance scene. Forest, hill, entrance scene. And then we should have a 8.6. Wait, 8. Here it is. Yeah. Okay, so it is there. Print out the ID. And the other ID. Wait, where is this? No, we don't have another ID. Okay. We just print out that ID there. Okay, so we have a thing there. It's destroyed. Okay, so let's check this out. So we load it in. It should say the ID. Explosive wall idle 8.6. Okay. 8.6. Yeah, that is correct. Yeah. So, but it's somehow it doesn't find it. in the map. Okay, so let's check the map. Load thing. I have to go here soon here, but let's see, where are we doing the map thing? Oh, the map. Okay. So another reason. Yeah, I'm not gonna have on it. Another reason here to use, since we have this pattern here, we can use the. Yeah. Thanks for joining. It was nice chatting with you. See you later. Let's see, we can use this again here. All right. Yeah, there we go. Okay. Okay, it didn't actually read in the data, so that was the problem here. I think. Let's just fix this and then I call it here. Okay, now we can go through. But that was not what we tried to do. Destroyed, yes. Let's load it in. There we go. Now it's gone. Nice. Cool. All right. And let's just check this here. The logs. Yeah. Very cool. So now it's destroyed here. And we will go to the debug stuff. Remove this. There we go. Same thing here. We could just iterate through. Well, I guess depending on the device type, we have to match the map here. But it is the same sort of pattern here going on. All right, and handle station. Yeah. I'm just gonna look through real quick if there's any other places we need to fix this stuff. Match map should really be moved into like Seabore. What else? Seabore. Save error. All right. A little less code to look through here. What do you call it? The locality, the concern. What is it called? The concern. Locality of concern. Division of concerns. Yeah, something like that. Inline for match map. Yes. So we could also put this in a function because it's a little bit arcane, even when looking at it right now, even after I typed it out. Is it a thing? No. Wait, yes. Oh, 1 second. Alright, so thanks very much for watching, and yeah, have a nice day. I'll see you later. Bye bye.